Second question says integrate 1 upon x square minus 9. How do we deal with this? Once again, the first important thing to note here is the degree of denominator, as you can see, is less than degree of denominator. So first step is okay. After that, we need to factorize the denominator. So let's focus on factorizing the denominator. X square minus 9 in the denominator can be factorized as x plus 3, x minus 3. Okay. This is x square minus 3 square, right, which can be factorized as x plus 3, x minus 3. And this can further be broken down into two partial fractions, a upon x plus 3 plus b upon x minus 3. This is what you have. Is that okay? Yes, that's okay. What else? What will be the values of a and b from here? So a and b can be found with the help of comparison of numerators. 1 over here in the numerator is equal to a times x minus 3 plus b times x plus 3, as you can clearly observe, right? This is what you can observe. And now by simple comparing coefficient of x and the constant term, coefficient of x, as you can see, is a plus b. On the left hand side it is 0 and here it is a plus b. Moreover, constant term 1 is equal to minus 3a plus 3b. Okay, so what do we observe? A plus b is equal to 0 and here I observe that a minus b is equal to minus 1 by 3, dividing by minus 3 throughout. So this becomes 1, this becomes minus 1 and this becomes minus 1 by 3. A minus b is known, a plus b is known, therefore a addition of these two will give me the value of 2a, which is minus 1 by 3, that becomes minus 1 by 6, and b over here becomes 1 by 6 with the help of this. Right, a and b have been found. Yes, a and b have been found. Okay, what else? Therefore, the integral will be equal to 1 upon x minus 3, x plus 3 dx. This becomes equal to integral of a upon x plus 3. A is minus 1 by 6. So this becomes minus 1 by 6 upon x plus 3 plus 1 by 6 upon x minus 3 with respect to x. This is what we are looking to integrate. And this further becomes, okay, minus 1 by 6 will come out, integral of x plus 3 in the denominator plus 1 by 6 times integral of dx upon x minus 3. Now this integral is not difficult, right? Minus 1 by 6 is okay, this becomes log modulus x plus 3 plus 1 by 6 log modulus x minus 3 is what I get, plus a constant term, right? And this is 1 by 6, this is 1 by 6, I can take 1 by 6 common, this is minus, this is plus, so log of m minus log of n becomes log of m by n, which is equal to log modulus x minus 3 at the top and x plus 3. Because of this minus sign, using properties of log, this is what I get, plus constant term. That is my required answer for this. 1 by 6 log of modulus x minus 3 upon x plus 3 plus constant, and that's all. Yes, that is all that you have in this question, but one important thing, right? And what is that? I want to share one important thing with you, and that important thing relates to this, finding the values of a and b. How can we find the values of a and b easily? Is there some shortcut for doing that? Yes, there is a shortcut. So let's look at that shortcut first. What do we have? We have 1 upon x plus 3 x minus 3 is equal to a upon x plus 3 plus b upon x minus 3. And let's suppose we want to find the value of a, just a. Okay, if you want to find the value of a, what I'll do is I'll multiply with this x plus 3 throughout. So x plus 3 will get cancelled from here, x plus 3 will get cancelled from here, and x plus 3 will come over here. First, this is what I'll do. I'll multiply with x plus 3 throughout. Okay. So this becomes 1 upon x minus 3, this becomes a, this becomes b times x plus 3 upon x minus 3. And now I'll put x plus 3 equals 0, which implies x equal to minus 3. Put x equal to minus 3 throughout. What does that give me? This becomes 1 upon, since this is true for all values of x, this is true for x equal to minus 3 as well, yes. So this becomes 1 upon minus 3, which is minus 6, is equal to a plus this minus 3 plus 3 becomes 0, this overall becomes 0. And do you see that I directly get the value of a, which is minus 1 by 6? Yes? Oh, that was easy, yes. If you want to find the value of b, what will you do now? So for finding the value of b, what I'll do is, I'll multiply throughout by this x minus 3. This x minus 3 will come over here and this x minus 3 will get cancelled. Okay, this is not cancelled now. This exists and this does not exist. Okay, and now for finding the value of b, I'll put that x equal to 3. So if x equal to 3, then what I get in the denominator, in the left hand side is 1 upon 3 plus 3, which is 1 upon 6, equal to a, the term with a becomes 0, and plus b, that gives me the value of b as 1 by 6. That looks pretty simple, yes. And is that some kind of a trick? We're following a proper method, just that we can skip a few steps and we can find the values of a and b easily using this idea. Now, how do we use this idea in general over here? So, finding the values of a, what you'll do is, this x plus 3 equal to 0 happens at x equal to minus 3. So, you'll forget this factor and you put x equal to minus 3 in the remaining expression on the left hand side, and what do you get? 1 upon minus 6, that gives you the value of a. Similarly, putting x equal to 3 here, after removing this will give you the value of b. So, imagine that x minus 3 has been multiplied, remove this x minus 3, therefore, don't worry about this, this will become 0 and you get the value of b as 1 upon 3 plus 3. That's the idea behind this, and this is how you can get the values of a and b in all such questions. Even in the previous question, when we go back to the previous question, I'll show you how to get the value of a and b. Once again, let's see, with this question only, I'll take you back to the previous question. So here at this stage, what I'll do is, if I want the value of a, I'll multiply throughout with x plus 1. Okay, so this becomes a 0, and after that I'll put x equal to minus 1. So this is removed, minus 1 upon 2 minus 1. What is that? Minus 1 upon 1. So the value of a should be minus 1. What about b? So we'll have to put x equal to minus 2 after multiplying with this. So minus 2 upon minus 2 plus 1. That is minus 2 upon minus 1, which is this 2. So that gives you the value of a and b. The idea we have discussed along with this question over here, and we have seen, okay, this exists. This is true for the previous question as well. You could see that. So finding values of a and b can be done using this approach as well, right? A pretty shortcut, you can say. Okay, but when you are solving for the board examinations, obviously will be you following this approach, not the shortcuts. You can check your calculations with the shortcuts, but yes, you'll have to solve with this approach only. And once you do that, yes, you get your correct answer. And that is all that you have in this particular question over here.